Let's go over this question. A particle moves according to a law of motion S equal to F of t, where t is non-negative. T here is the time measured in seconds, and S here is the position measured in feet. So this is the position function of this particle. First question, find the velocity at time t. Since we are given this position function, velocity is the derivative of this position function. So we differentiate that position function here. The derivative sine is cosine. So we have cosine of pi t over 2. But don't forget, by the chain rule, we have to multiply this by the derivative of this inner function. The derivative of this inner function with respect to t is pi over 2. So this will be the velocity at time t, and the unit is feet per second. Second question, what is the velocity after 1 second? Since we got the velocity function, so all we have to do is substitute t equal to 1 and find out the velocity after 1 second. Since cosine of pi over 2 is equal to 0, 0 times pi over 2 will give us 0. So the velocity after 1 second is 0 feet per second. Question C. Where is the particle at rest? The particle is at rest when the velocity is equal to 0. So we are going to set the velocity equal to 0, which is this pi over 2 times cosine of pi t over 2 equals 0. Divide both sides by pi over 2, we get cosine of pi t over 2 equals 0. Solving this trig equation, we have pi t divided by 2 is equal to pi over 2 plus n pi. Now divide both sides by pi over 2, we get t is equal to 1 plus 2n, where n here is equal to 0, 1, 2, 3, 4, etc. So n here is a non-negative integer because we're given that t has to be greater than or equal to 0. So we don't regard those negative n. Now you can actually see the t over here from the graph of this function cosine of pi t over 2. This is the graph for this function. And you can see that this function, the function value equal to 0, is going to add 1, 3, 5, 7, etc. So the particle is at rest when t equal to 1 plus 2n. This stands for an odd integer, and we only consider positive odd integer, and which means t here has to be 1, 3, 5, 7, 9, etc. Next question. Where is the particle moving in the positive direction for t greater than or equal to 0 and less than or equal to 6? The particle is moving in the positive direction when velocity is positive. Therefore, we're going to set the velocity greater than 0. Setting velocity greater than 0, we can divide both sides of this inequality by pi over 2. So cosine of this quantity, pi t over 2, will be greater than 0. Let's take a look at the graph for cosine of pi t over 2. You see that the function value is going to be positive here and here. The corresponding t will be from 0 to 1 and 3 to 5. So that we can conclude that velocity is positive on 0 to 1 and also 3 to 5. Here we'll include 0 because when time t equal to 0, velocity is positive. So we're including 0. But then here we exclude 1 because when t equal to 1, velocity is 0. It is not positive. Similar here, we don't include this at 2n because velocity will be equal to 0 at the 2n here. So this is open interval. And this is for t greater than or equal to 0, less than or equal to 6. So positive velocity, and then here negative velocity and negative velocity. Next question. Draw a diagram to illustrate the motion of the particle and use it to find the total distance traveled during the first 6 seconds. So from 0 to 6 seconds, and we're looking at the graph over here, we see that velocity is positive here and negative here and here. So you see the particle is going to move to the positive direction. Let's define the positive direction as moving to the right. So positive direction here when time is between 0 and 1 second. And then afterward, it's going to go backward because you have negative velocity. And then from 3 to 5 seconds, velocity is positive, so moving to the positive direction. From 5 to 6 seconds, velocity is negative, so moving to the negative direction. Now, to find out the total distance traveled, we can use the position here, subtract the position here, to get the distance traveled. Actually, we're going to take the absolute value of the difference of the position to find the distance traveled at each one of these time intervals. So we're going to take f of 1, which is the position when time t equal to 1, and subtracting f of 0, which is the position in the beginning, and we got 1. It is positive, 1. And then we take the position at time t equals 3, subtract the position at time t equal to 1, so we got negative 2. Remember, it is negative 2 because we're moving to the negative direction, so the change in position is negative. However, since we regard distance, we can take the absolute value of this to find the distance from here to here. Similarly, we found the distance over here by using f5 subtract f3, we got 2. And the distance over here is going to be f of 6 subtract f of 5, and then take the absolute value of that. So take the absolute value of those results we got over here. We got 1, adding absolute value of this is 2, and then plus 2, and then plus the absolute value of this one, which is 1. So the total distance traveled will be 6 feet. Next question. Find the acceleration at time t. Now we've got the velocity function. Acceleration is the derivative of the velocity function. So differentiate this with respect to t. The derivative cosine is negative sine. So we get negative sine of pi t divided by 2. And then here we have the pi over 2 here. But then remember the chain rule. We have to times the derivative this in the function. The derivative this in the function with respect to t is pi over 2. So we multiply over here. Simplifying this, we get negative pi squared over 4, and then multiply with sine of pi t over 2. The unit here is feet per square second. Now, find the acceleration after 1 second. All we have to do is substitute t equal to 1 into this acceleration function. Since sine of pi over 2 is 1, acceleration after 1 second is negative pi squared over 4 feet per square second. Next question. Graph the position, velocity, and acceleration functions for t greater than or equal to 0 and less than or equal to 6. So here's the position function, here's the velocity function, here is the acceleration function. Remember, we are allowed to use graphing calculator. It said that it's recommended to use a graphing calculator. So we can just enter all this function. So the position function is the blue one over here. The velocity function is this red one over here. And the acceleration is the purple graph over here. Next question. Where is a particle speeding up? The particle is speeding up when velocity and acceleration have the same sign. Looking at the graph for the velocity function and also the acceleration function, we see that the velocity function, you see here, is above the t-axis. So it is positive, and here is below the t-axis, negative, and velocity here is also negative, and here above this t-axis, so it's positive, and here is also positive, and here below the t-axis, negative. Acceleration is going to be negative here, also here, and positive here, and here, and then here is negative, and here, see, is below the t-axis, so it's negative. And now we see that the particle is speeding up when velocity and acceleration have the same sign, which is going to happen over here, here, and here. The corresponding time interval will be from 1 to 2, and from 3 to 4, and also from 5 to 6. Let's write it in time interval. So it is speeding up when t is in 1 to 2, and also 3 to 4, and 5 to 6. Last question. When is the particle slowing down? The particle is slowing down when velocity and acceleration have opposite sides. So the particle is slowing down when t is in, you can see here it is actually right here, slowing down because this is an opposite side. So when t is in 0 to 1, also 2 to 3, and 4 to 5. When velocity and acceleration have opposite side, the particle will be slowing down.